In this experiment, we're going to be discussing polarimetry and the specific rotation of an optically active substance, that is sugar solution. So, what is polarimetry firstly? So, polarimetry is a technique which measures the rotation of plane polarized light when it passes through an optically active substance. What is an optically active substance? So, the substances which have chiral molecules in them, that is, molecules that are not symmetrical or cannot be rotated around an axis of symmetry. Such molecules are chiral molecules. So, when optically active substances have light pass through them, they rotate the plane of polarization of the light either clockwise or anti-clockwise. So, the rotation that this causes is called optical rotation, and it depends on many factors, which could be molecule structure, rotation, concentration of the substance, light's path length, and other factors. So, polarimeter's job is to measure the angle of this rotation by comparing the position of the light before and after passing through the substance. The theory behind the experiment is very simple. So, when plane polarized light passes through the sugar solution, so basically, you might question how the light is plane polarized when it's coming from a simple sodium vapor lamp. So, the point here is that firstly, the polarimeter collimates the light, that is, makes it into parallel beams of light, and then it passes through a Nichols prism, which converts it to plane polarized light. Then it's passed through sugar solution where it gets rotated, and then it's passed through another Nichols prism which helps us to analyze the rotation caused. So then when the light passes through the sugar solution, it gets rotated by an angle, and that angle is proportional to the sugar solution's concentration as well as the length of the tube. So the half-shade polarimeter can precisely measure the optical rotation caused by the sugar solution.
So this is the polarimeter. It consists of the slit from where the light source comes. So the light source will basically be a diverging light source starting from the slit. So here you'll have firstly a convex lens which converts the light into a plane wavefront or parallel lines, parallel beams. Then you have an Nichols prism here which converts the unpolarized light into plane polarized light. So then this passes through a half shade plate which is represented by H in the diagram, and then here we will be placing the sugar solution tube. Then another Nichols prism will be found here, and finally here is the eyepiece through which you can observe the light. So this Nichols prism is the analyzer, the one present after the sugar solution tube. Here you can see two eyepieces. So the first one is to view the circular scale and take readings precisely, while the second one is to view the plane polarized light, which the analyzer, which will be found inside, which the analyzer sends towards the eyepiece. So this is the eyepiece that you will be observing the light.
Finding the concentrations of the sugar solution being used is very simple. So, when you start, you use 5 grams of the sugar solution dissolved in 25 centimeter cube of the water. So, the concentration when converted to SI units will be 5 grams is 5 into 10 power minus 3 kgs. That is divided by 25 into 10 power minus 6 to get it into meter cube, which gives you 200 kg per meter cube, which is 20% sugar solution. Similarly, 5 grams per 50 centimeter cube will give you 100 kg per meter cube, and then 5 grams in 75 centimeter cube gives you 66.67 kg per meter cube.
Few preliminary things. You can find the least count of the vernier scale in the circular scale which you can see. So basically, one main scale division, as you can see, represents 10 degrees, whereas the number of divisions on the vernier scale goes from 0 to 10. So now the least count of the scale will be 10 degrees divided by 10 divisions, which is 1 degree, or you can also call it 60 arc minutes. Now, for the first part of the experiment, you will be filling this tube with distilled water up to the brim. The attendant will do that. And you will have to make sure that this air bubble is not present anywhere in the tube, but rather comes to this central bulge so that it will not come in the path of the polarized light. Place the tube inside this and close it. And this tube, at first I have filled it with distilled water, and as we proceed in the experiment we will be replacing the distilled water by sugar solution of varying concentration. So here you have the eyepiece, and basically when you rotate, so there will be a Nichols prism after the sugar solution tube. So when you rotate that Nichols prism, so in the eyepiece you will have a central division line, and the light on both the sides of that will be of varying intensities. So when you're taking the reading for the distilled water, which is the reference reading, you have to, I can't really show it here, but when you look through the eyepiece, you can either see both the sides are equally bright or both the sides are equally dark. So, or one side is dark and one side is light. So as you rotate the second Nichols prism, the intensity of one side will keep changing with respect to the other. So now when you're taking the reference reading, you have to, as it says here, you have to rotate the analyzer, which is the second Nichols prism, so that the two halves of the field of view will be equally bright or equally dark. So until that happens, you have to keep rotating it, and you can note down the reference value. So this is how you do it. So for distilled water, you note down the main scale reading, the CVE and least count, and you can find the reference reading. And now you have to replace the distilled water with sugar solution of 200 kg per meter cube concentration. So for that, you'll have 5 grams of sugar dissolved in 25 centimeter cube of distilled water, and that will be added the to the tube that we're using, to this tube. And once again look for air bubbles in the tube and place it back inside. And now once you close it, you have to start taking read. So you might remember that when you took the reference reading, the two halves were either completely dark, equally dark that is, or equally bright. So now when you fill the 200 kg per meter cube concentration sugar solution, it will no longer be of equal brightness. So one side will be darker than the other, or alternately brighter than the other. So now you have to once again rotate this dial of the analyzing prism inside until the two sides become equally intense, that is equally dark or equally bright, whichever you prefer. Once that is done, you have to note down the reading in the scale, and once that is done, so the reading will basically work like this. So when I did the experiment, you have to basically, for the first reading, since the concentration increased from 0, which was distilled water, to 200 for the first sugar solution, because the concentration is increasing, you have to rotate anti-clockwise to take the first reading. So when you rotate the dial until you get equal intensity, once that is completely done, you have to note down the main scale reading, and as we did it for R0, the same way. So you have to note it in theta in degrees, and now you have to find R1 minus R0. So R0 was our reference value. So basically to find this, because the main scale readings will all be going behind the 0 scale, so you have to convert it into a comparable value for R0, which was this 2 degrees 24 seconds for me. Again, it will be different for everyone, but in such a case you have to subtract 360 minus this total reading and then add it to R0, so that you can find the value of R1 minus R0, which is theta. So when you find it in degrees, you can convert it to radians by doing pi by 180 times of the degree value. So when you have degrees and minutes, you should be converting it to seconds and then finding it in radians. Or since you'll be using a calculator, you can directly input it. And once that is done, once you have the radiance values. And like I said, firstly we did this with 200 kg per meter cube concentration. But once that is done, you will be emptying it back to the beaker and diluting it by adding another 25 centimeter cube of water and filling this new solution into the tube, which will now be of 100 kg per meter cube concentration. And again repeat the same process. Once you place the tube back inside the polarimeter, you will no longer see the two sides of equal brightness. So once again, one side will be darker and one side will be brighter. And this time again, you have to rotate the tube. So you will be rotating the Nichols prism once more. And this time, because the concentration is decreasing from the previous one, you'll be rotating clockwise. Likewise for the next trial that we'll be taking. So when you get equal intensities, once again note down the degree value. Find R1 minus R0 by subtracting 360 minus this total reading and then adding R0. So once that's done, convert it to radians as usual and repeat it for, once again you'll have to dilute it, get it diluted, and this time it will be 66.7 kg per meter cube. I'll explain how the concentration is found. And once that's done, you have to again, like I said, the brightness will be different from before. The brightnesses were exactly the same, but once you add a new concentration, once again you'll have to rotate it by a certain amount to get equal brightness. When you get that, you can note down the main scale reading, CVD and total reading, find the value of R1 minus R0, find it in radians, and that's the tabular column. So now you have to do theta. So this is the value of theta in radians, and C is basically our concentrations in kg per meter cube. Everything has to be in SI units. So when you are finding theta by C, you have to divide this by this, and these are the values that you will be getting, and then you have to find the mean of the three values to get theta by C. Finally, you have the specific rotation, which is the measure of theta by LC. So L is basically the length of the tube that we'll be using. So this is the tube, right? You have to measure the length from this end to this end, which is the region where the optically active sugar solution is placed. So once you find that length, you can find specific rotation as equals theta by LC. So it will be in radians meter square per kg.
The graph that we're going to plot will have the concentration on the x-axis in kg per meter cube, and on the y-axis it's going to have the angle in radians. So that's the readings that we took. So when you plot the graph, you're going to get a straight line graph, and when you find its slope, the slope is going to be substituted into the formula slope is equal to theta by C, which is what you're going to write down, and then the formula used will be specific rotation is equal to slope divided by L. It's the same formula that we used in the theory calculation, except theta by C is given by slope. So you directly substitute the slope. And the conclusion from the experiment is basically that the values of the specific rotation by calculation and by graph are very similar to each other. So the experiment's a success.